Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to do a Unit 5 review on series circuits. First of all, a series circuit is going to be defined as a circuit that has only one path for current flow. What we're going to see in Unit 6, in parallel circuits, we're going to have multiple paths for current flow. So I've drawn a series circuit. I have the schematic symbol for a battery with polarity, plus and minus here, represented by V sub T, or total voltage. And in the series circuit, I have three resistors, R1, R2, and R3. I've given a direction of current flow using conventional current flow. Remember, there was conventional current flow and electron flow. Conventional current flow simply means the polarity designation. Current flow leaves the positive terminal of the battery, goes through each of the resistors, and then returns back to the negative terminal of the battery. So the three rules for series circuits: Req, the equivalent resistance, or the total resistance, is equal to the algebraic sum of R1 plus R2 plus R3. Second rule in a series circuit: the current I is the same everywhere. So once we calculate using Ohm's law the current I, it's going to be the same through resistor 1, it's going to be the same through resistor 2, and it's going to be the same through resistor 3. And the last rule, the total voltage, V sub T, is going to be equal to the sum of the voltage drops in the circuit. So V sub T is going to be equal to the voltage drop across resistor 1, plus the voltage drop across resistor 2, plus the voltage drop across resistor 3. So to give a concrete example of this, I'm going to put some numbers on our circuit. So again, I have a series circuit. I have a 12-volt battery. I have three resistors. R1 is 4 ohms, R2 is 3 ohms, and R3 is 5 ohms. So we're going to find everything. First step is to find the equivalent resistance value. So Req is equal to R1 plus R2 plus R3. So 4 ohms plus 3 ohms plus 5 ohms. 12 ohms is the equivalent value of resistance for the circuit. Step 2, using Ohm's law, I'm going to calculate what the current in the circuit is. But remember, in a series circuit, the current is the same value through each of these resistors. So I is equal to V divided by R, specifically V sub T, which is the supply or the total voltage, divided by that equivalent R, Req, that we just got. So supply voltage is 12 volts. The equivalent resistance we just calculated is 12 ohms. 12 divided by 12, 1 amp of current flow. So what that means, the 1 amp of current flow goes through the 4 ohm resistor, R1, goes through the 3 ohm resistor, R2, and goes through the 5 ohm resistor, R3. The last step is to calculate each of the individual voltage drops. And then we have to add these together to see if they do equal the supply voltage. So again, using Ohm's law in a different form, this time V is equal to I times R, current times resistance. I'm going to designate the voltage drop across resistor 1 as VR1, the voltage drop across resistor 2 as VR2, and the voltage drop across resistor 3 as VR3. So in the case of R1, I times R1, the 1 amp of current we calculated multiplied by the 4 ohm resistor, gives us a voltage drop of 4 volts. For resistor 2, same current flow, 1 amp times 3 ohms gives us a voltage drop of 3 volts. And across R3, same current flow of 1 amp multiplied by 5 ohms gives us a voltage drop of 5 volts. So now we have to see if what we did is correct. The sum of the voltage drops in a series circuit has to equal the voltage rise or the battery voltage. So simply add all these together. 4 plus 3 plus 5 gives us 12 volts, and that indeed is the supply voltage. Thank you.